Okay, good morning. Again, we're gonna do this every Monday, Wednesday, Friday as far as the class goes. Um, Same thing that I said earlier. Some of you may not have seen it when I had said it earlier, but again, you only have to attend one. That's so I can count you as having a live interaction at least once a week. However, again, there will be a new class every Monday, Wednesday, and Friday. So the ones that I have scheduled there, I'll try to hold class every single one of those times, as well as I'll also have the office hours on Tuesday and Thursday. Um, Again, all that information is posted on Edsby. I know Edsby's been kind of slow, so it's been a little bit rough as far as what um, what you're able to accomplish when you're going on Edsby, especially if it's in the morning. But again, do the best you can. I'm going to try to make most assignments due later in the day. Like I'll probably set it to 11 o'clock at night. If I accidentally put it early, uh, I'll I'll usually try to catch it and change it. If you guys see that I have something scheduled due way early in the day, let me know. I'll change it. I posted an attendance question last night so that you should be able. Yeah, in just a second. I posted an attendance question on Ensby that you should be able to do. Again, it doesn't matter what time you do it. Try to get the attendance question done by 3 o'clock. That way I can have attendance done by the end of what the normal school day would be. Um, Again, to answer your question again, that was, you only have to attend one of these throughout the week. Again, Monday, Wednesday, and Friday will be live. It'll be a different class each of those days. You can ask questions at the end of class. Tuesdays and Thursdays, those are going to be the office hour days. So the URL link that's down there at the bottom, the one that's the tinyurl.com, that's the same. That's for the same folder that you have on Edsby off to the side, but Edsby's been running very, very slow. So I just went ahead and wrote it on the bottom of this. That way, hopefully, if you're having trouble getting to things on Edsby, you'll be able to get to them there. Everything that I'm posting on Edsby, I'll be posting that folder as well. Now, for class today, I did make notes. So again, there's a guided notes document. If you want to use it, you can print it off. You can use it. If you want to jot them down later, that's fine. Again, I'll take a picture of my notes when I'm done, and you can take notes afterwards as well. For the first assignment will be doing the notes, whether it's on your own paper, whether it's doing it off a printed copy, whatever. But make sure you take a picture of it, send it to me. Again, the way you submit that is on Edsby. There'll be a submit button for the first thing for notes. Again, I don't have the time due until later tonight. And then there's a second assignment on Edsby that's due tomorrow. That's out of the textbook. Again, I also attached a picture of the textbook to the assignment. So in order to see any pictures or attachments on any assignments, you have to make sure you click on the assignment when you're on Edsby, and then you're able to go to it. Or again, you can go to that OneDrive folder and it'll have the attached, everything that I'm attaching on Edsby will be in that OneDrive folder. I know Edsby has been very slow. That's why I'm having that backup with that OneDrive folder. So if at any time you need to get something from that OneDrive folder, here, I'll post the link right here. Again, that's the link. So if you're having trouble accessing Edsby, if you click on that link, that should take you straight into the OneDrive folder that is shared with everybody in this class. Again, as long as you click on that link, it'll take you to the OneDrive folder. Yes, you do have to log in order to view it. So it's your normal student number at hcps.net, and then your regular password. All right, but again, that's what it should look like. So let me bring it up so that you can see that as well. Share screen. So the OneDrive folder, That's what it looks like right now. So if you click the link, it'll take you to a folder that looks like this. Whenever you go to it, there's a folder for Geometry Honors, there's a folder for MCS. So you're just use the Geometry Honors one. The introduction thing that I had done the other day on Thursday and Friday is also already in here. Under this folder, you'll see that there are a couple things right now. Again, the only things that are in here are the guided notes that I had made, both as a Word document and as a PDF, and then also a PDF of the textbook pages that are due to you. Yeah, so again, like I said, for Edsby, I know Edsby is not working very well. That's why I keep getting messages about Edsby not working. Yes, Edsby's very sluggish. It takes a long time for anything to load. That's why you can use that link. Again, I'll post that link one more time. And then let's go ahead and get started with some notes. So I'm going to switch this over to a document camera. Oh, hold on one second. Let me make sure I can view this correctly. All right. So again, this is the worksheet that I was saying that I had posted to Edsby, or I also posted in the OneDrive. If you want to use it for notes, you can. If not, again, you can write on whatever you want, but one of your first assignments is doing some notes. So I'm going to try and do this as quick as possible so that if there's any questions at the end, we can get to those. For right now, again, what we're working on today, we're looking at a lesson on circles. Everything in chapter 10 is all about circles, but now we're talking about actual, not just on a graph. So I think this section is a little bit easier than the last one. There's some vocab there to start off. So we gotta know some basic things about circles. Central angle, intercepted arc, circle measure, minor arc, and major arc. So for the central angle, and central angle is gonna be, let me draw a diagram first, it'll help out. If we have a picture of a circle over here, then we're going to have an angle drawn from the center point. This is what's called a central angle. So a central angle is an angle formed by two radii and the arc. So a central angle. I'm going to write the definition straight from the book. Central angle, an angle formed by two radii with the vertex on the center of the circle. All right. So again, that's a central angle. Now, an intercepted arc. An intercepted arc is actually the arc that the central angle intersects. So anytime, now it doesn't even have to be a central angle, but it's really just anytime an angle intercepts any arc on a circle. So an arc that is created by the intersection of an angle line or, whoops, or any part of a line. Now, that's a little more broad definition than what the book uses, because the one in the book specifically refers to an angle intercepting the arc, because again, our focus right now is on these central angles in this lesson. So if I draw the same thing in the first picture that we had, again, the central angle is this part. This could be an example of an intercepted arc. Now, you actually have two different arcs that are intercepted arcs when you have an angle intercepted, because you have this little one, but on the other side, you also have this big one. Now, the circle measure, all right? So circle measure is something that we've already talked about. A circle has a measure of 360 degrees. So again, if you're going from a point, a circle is 360 degrees all the way around, because again, around any single point, you have 360 degrees. So when we're talking about measure, we're going to be talking about the measure of the arc compared to the measure around the center point of the circle. So the next one on here is minor arc. A minor arc is an arc that is smaller than a semicircle. So an arc that is smaller than a semicircle. So again, a semicircle is half of a circle. So a minor arc is going to be an arc that's smaller than it. So if I draw the same diagram again, this time, again, I'm going to actually give this a measurement. So this angle, let's say that it's 80 degrees. Well, then this arc would also be 80 degrees. So it's smaller than a semicircle, and its measure is going to be between 0 degrees and 180 degrees. Now, there's also naming that's involved. In order to name a minor arc, you're going to have points. I'm going to call this circle P for right now. So this is circle P because the center is P. And I'm going to label this A and B. So this is the minor arc AB. And the way you would write that is just like that. And you only have to use 2 letters to name a minor arc. And yes, I will post these notes to EDSB. So if you missed it at the beginning, all the notes that I take on here, I will also post that on EDSB at the end, because again, this is going to be one of your assignments, and I want to make sure that everybody's able to complete it, whether or not they were able to attend today. So again, you need to make a handwritten copy of your own notes and post them to EDSB. Now, major arc. A major arc is going to be an arc that is greater than a semicircle or larger than a semicircle. An arc that is larger than a semicircle. Now, same way that we did the other diagram, I can actually draw the same diagram again. I'm going to draw the same circle. I'm going to still say that this one is 80. But instead of looking at the little arc, we're going to look at this big arc. And if it's 360 degrees all the way around the circle, then this part is going to be 280 degrees. So this arc is 280 degrees. Now, again, for the measure, so the measure of a major arc is going to have to be between 180 degrees and 360 degrees. As far as naming goes, again, I'm going to use the same points. So this is circle P still. We have, this is still A, this is still B, but I couldn't say arc AB, because if I just said arc AB, I'd be talking about this little arc. So now, in order to name this one, I need another point. So I'm going to put C over here. And it doesn't matter what point, if I could have 3 or 4 different points over there, it doesn't matter, but I need the 2 endpoints and any point that's in between it. So this arc could be arc A, C, B. However, let's say I'd put another point there. Let's say I'd also put D on there. This same arc could also then be named with A, D, B. Again, it does not matter what point, if there's more than one point, it doesn't matter what point you would be using in between the other two. That point in the middle is just showing the direction that you're going around the circle. Right. Any questions so far? All right, Ted, you have a question? You have a mic?
I was asking about the attendance for today, but I found out how to do it, so I'm going to just turn my raise hand off.
Okay, all right. Anybody else have a question right now? No? Yeah, let's see. Yeah, and again, at the end of this, you guys can always pause it. I'm trying not to take up too much of anybody's time as well, so I'm going to try to keep these notes for the most part between that 30 to 45-minute window that I had said in the introduction. So I'd like to be done with these notes by, what is that, 11 o'clock. Again, if you need to go back, the video will get posted to Edsby with a link to YouTube. So again, you can get it from there. I'll also be posting the links in that OneDrive folder. So the note document is, again, it's posted on Edsby. It's attached to the notes assignment. So you'd have to click on the notes assignment to get it from Edsby. Or if you click on the OneDrive link, you can get it from that folder. All right. Can I reread which part? This part? So an arc, I'll just go through them real fast again. So back to the top. So again, a central angle, an angle formed by 2 radii with the vertex on the center of the circle. An arc, sorry, an intercepted arc is an arc that is created by the intersection of an angle, line, or any part of a line. The circle measure, a circle's measure, I put of instead of is. A circle has the measure, oh sorry, no, a circle has the measure of 360. No, that's the correct phrase. All right. Minor arc, an arc that is smaller than a semicircle, so between 0 degrees and 180. A major arc, an arc that is larger than a semicircle, so between 180 degrees and 360 degrees. Right. Let me go back through and just read some of these. All right, I think I got everybody's questions. All right, let's keep going then. So a couple important concepts of arc measure. It's important to know that the measure of an arc is equal to measure of its corresponding central angle. So if you say you have a circle, and we have a central angle, and we're going to label this, I'm going to go with O this time. We'll call this X and Y. So based on this diagram, the measure of angle XOY is going to be equal to, so now we're looking at this minor arc here, is going to be equal to the measure of arc XY. So that'd be the correct way of saying that they're equal. And again, they're equal because if this is, let's say this time, this is 70 degrees, then this is going to be 70 degrees. So the intercepted arc, the minor intercepted arc with a central angle would have to be equal or congruent in measure. All right. The next one, congruent central angles. If you have congruent central angles, then their intercepted arcs will be congruent. So if I drew two different angles here, and so this angle is congruent to this angle, then this arc is going to be congruent to this arc. So let's give these some names here. So I'm going to call this circle T. So be G, H, and J. So if both of these are central angles and they are congruent, then what we're saying here is if angle GTH is congruent to angle JTI, then arc GH is congruent to arc IJ. Sorry, arc. Let me erase that. Not line segment. Now, for the little try it down here. So we have a couple questions. So it says use W. All right, so here's circle W. There's circle W. What is the measure of arc XZ? Oh, thank you. JTI was what that was supposed to say. Okay. Now, if that's 115, then XZ should also be what? 115. That's it. For B, what's the measure of arc XYZ? So XYZ is on the other side. So then all we're doing is taking a full circle, which is 360, and subtracting the 115. So what's 360 minus 115? Close. 245, right? All right, so that's all you're doing on that type of problem. Now, we do have different types of measurements for a circle. So I had told you guys that we'd worry about radians later on. Well, now it's later on. So we're talking about degrees versus radians. So when we talk about a circle has 360 degrees. 360 degrees in a circle. So if I was to draw a circle, and I would say, I'm going to start here and go all the way around. So going in this direction, we'd have 0 degrees. If we got up here to the top, this would be 90 degrees. Came all the way over here, that's 180, 270, and then came all the way around, we'd be at a total of 360. Well, for radians, there's 2 pi in a circle. So radians is a different type of measurement, and it's based on units of pi. So same diagram. So again, if we're rotating around this way, we start off, we have 0 pi. If we came all the way around to this side, I'm going to go ahead and extend that. Came all the way around to this side, this would be pi, and this over here would be 2 pi. Now, just like I had the other measurements on this one, I could do the same thing here. So if this is pi, at this point, I'd get a half pi, so pi over 2. And if I was going this way, well, I'm 1/2 past the full pi, so that'd be 3 pi over 2. And next year, when you do Algebra 2, or for trig or pre-calc, you start doing a lot more with radian measures, and there's something called a unit circle that you will have to memorize. This is the start of the unit circle. So again, there'll be a lot more to this. We only do a very small amount with radians, but this is the basic for what radians are. Now, radians, by definition, are actually based off the length of an arc when your radius is 1. So like if the radius was 1 here, this length of this arc is actually pi. The circumference of this entire circle is 2 pi if the radius is 1. So again, that's getting a little bit more into trig. So moving on, converting. Now, if you're given something in degrees, you can always convert it to radians, or if you're given something in radians, you can always convert it to degrees. So starting with, if you had something in radians, let's say you had the measurement of 3 pi over let's do, no, that's not a good division. Let's do 3 pi over 2. All right, so radians to degrees. If I want to convert this to degrees, all we're going to do is multiply by 180 over pi. Now, why would we do this? Notice, pi and 180 are in the same place. So in order to convert, you always convert by multiplying by things that are basically equal to 1. What this is doing is, since these are the same, this value is 180 degrees over pi radians, this is essentially the exact same value. So this is equivalent to 1. So when you multiply here, you cancel off pi, and then we could go ahead and multiply this out. 3 times 180 over 2. If we, again, doesn't matter if you multiply first or divide first. So you could say 180 divided by 2 is 90. 90 times 3 is 270. And this would be our measurement in degrees. So again, when converting from radians to degrees, what we're doing is multiplying by pi over 180. So again, times by, oops, I just said that backwards and started writing it backwards as well. Let's try that again. Times by 180 over pi. So now, radians, if we're going to radians, we're going to do the exact opposite. So this one will be times pi over 180. So on here, same thing. I'm going to give us a number. Let's go with 60. So I have 60 degrees. I want 60 degrees to be in radians. Well, we would multiply 60 degrees by pi over 180. So pi over 180. When you do that, you get 60 pi over 180. Reduce it. First, we could go ahead and reduce the 0 by dividing by 10. And then we have 6 over 18. So both of those are divisible by 6. So that's now just 1 pi. 18 divided by 6 is 3. So we have pi over 3, or 1/3 pi. Now, there are some that reduce very nicely. We had our special right triangles, and that does relate back to this. Special right triangles included angles of 45, 30, 60, and 90. Those at intervals all the way around the unit circle give us pretty nice fractions. Again, those are going to be part of your unit circle when you get into Algebra 2 and trig. All right, so now arc length. So arc length, this is actually the distance along an arc. The distance along an arc. So what we're looking at, I'm going to draw 2 images that are very similar on here. We're going to say that this is 90 degrees on this one. We're going to say that it's pi over 2. Now, arc length in degrees. Well, if I want to find the length of this arc compared to the length of this arc over there, again, there's 2 different ways to find it. So if it's in degrees, there's one method. If it's in radians, there's another method. Now, you could actually go through and set up proportions, and the book walks through doing a proportion to get to the equation. I'm going to go straight to the equation. So arc length for degrees can be found by doing the fraction of the circle that you're using. So this is giving us a measure in degrees out of 360. And this is a fraction of the overall circumference. So the circumference of the circle is found by 2 pi r. So this is our equation when given a measure in degrees. Now, our arc length for a radian is a little bit different. And I don't have a good reason for this, but a lot of times they refer to the arc length as S, which again, don't have a good reason for that, but I'm going to do this slightly different. Oops, sorry, arc length. We have the final equation, if you work it all out, is actually just theta times r. Now, the reason why I'm using theta here, and I mentioned it way back when we did circles the first time. Here, m is representing the measure in degrees. Theta is going to represent the measure in radians. Now, this formula does look much simpler, and it is. It just simplifies a lot nicer after you've taken into account some of the other variables will cancel out since they're already in terms of pi, whereas this one has pi in it. But if we plug into these two equations, so for this example, I need first a length here. So I'm going to say my radius is 3. So we're going to have L equals 90 over 360 times 2 pi 3. This is essentially 1/4 of a circle, so 1/4, right? And that reduces down. 2 times 3 is 6. 1/4 of 6 is 6/4 pi. All right. Now, on the other one, all right, I'm giving us the same radius of 3. Oh, this could be reduced more. Hold on, let's go one further step. 6 divided by 4 can be reduced to 3/2 pi. So that's in terms of pi. Coming over here, same problem essentially. We have pi over 2 times a radius. Well, 3 times pi over 2. That and that are the same thing. So again, much simpler formula. Unfortunately, most of what we're going to be doing still will be in degrees. But if you want to convert, you can always convert and use the other formula. It works. So again, if you want to convert first, either one of these do work. All right, down there on the bottom. So there's some examples, kind of small. So it says in a circle with a radius of 4. So I'm going to draw it. We have a radius of 4. What is the length of an arc that has a measure of 80 degrees? So 80 degrees. So on this one, again, using this arc length formula is the fraction of the circle that we're using. 80 out of 360 times 2 pi r, which in this case is 4. And we're just multiplying. If you want to use a calculator on that, you can use a calculator on that. So 80 divided by 360, which if you wanted to simplify is this. Again, you don't have to simplify. So again, keep multiplying it out, times 8. In terms of pi, would be 16/9 pi. If we wanted to change it to a decimal, again, times 3.14, 5.58. On this one over here, they say that we're given a circle with a radius of 6, an arc length that has a measure of pi radians. So pi radians. Right. All we're doing is arc length equals the radius that they gave us, which was pi, times 6. So we're just going to rewrite that in the other order. 6 pi. That could be an answer. Or if we were to multiply it out, 6 times 3.14, that's 18.84. And that's it. All right. There's one other thing that for this section, which is area. Now, I know I spent a little time at the beginning going over other things. So if you need to go, if you have another class, that is fine. I'm going to go ahead and finish area. But again, there's two area things, area of a sector and area of a segment. But again, we'll be posting this video. Here. Just that final thing. There you go. So sector of a circle. Let me draw a diagram first. This is a sector. It looks like a pizza slice. It's a wedge, right? So a sector, right, is part of a circle bordered by two radii and an arc. That's a sector. Find the area of a sector, a lot like arc length. So in this one, we did the fraction of the circle we're using times circumference. Here, we're doing the fraction of the circle times area. So area of a sector is found by doing the measure over 360 times pi r squared. Now, that's our equation. So we have two examples here of how to use it. So let me push this up. And the focus works. There it is. All right. So now, on the next one, what is the area of each sector? So again, we're just plugging into this formula. So we take 165 over 360 times pi, r in this case was 3, so 3 squared. Now, if you want to simplify, again, you're more than welcome to simplify first, but some of these numbers get kind of crazy, so you don't have to simplify. That's 11 out of 24 times, essentially, again, this is our area of the entire circle. Now we're just multiplying by the fraction of the circle that we're using. So times 9. If we wanted to leave it in terms of pi, it'd be 33/8 pi. Or multiply it out by 3.14, you'd have 12.9525. Those would be our answers. On this one, same idea. So again, 59 out of 360 times pi r squared, which is 10 here. So again, just multiply the whole thing out. You can type the whole thing straight into the calculator. So 59 divided by 360 times 10 squared, or times 100, 16.38 pi. Again, multiply it by 3.14, and you have 51.461. So then on this last part, segment of a circle. So segment of a circle is a little bit different. It's going to actually require two equations. So we just talked about what a sector was. A segment is that piece there. So A segment is going to be a part of a circle that is bordered by a, do they use the definition of chord yet? No. Okay, so this is in the next chapter, but this piece here, this line, is called a chord. So I want to go with an easy definition right now. The easiest definition for a segment is a part of a circle bordered by a chord and an arc. So again, it's kind of like the crust of the pizza there, but it's just a straight line, right? And it's that piece in between. So in order to find area of a segment, there's two parts to this. You still have to find area of the sector, but then subtract off the area of that triangle that's not being used. So area of a segment. Again, you're doing the sector minus the triangle. So if you put it all together, you have pi, oh, sorry, not pi, m over 360 times pi r squared minus the triangle. In this case, the piece that you're going to have for this triangle, you're going to have the radius and you're going to have the measure of this angle. So we're actually going to use the equation of a triangle from the last from 2 sections ago that used 2 sides and an include angle, which was 1/2 AB sine of C, which in this case, A and B are both the radius, so r squared, sine of m. Again, we're not going to have to do a whole lot with this one. I'm going to try and stay away from segments. That's the most confusing equation that you'll see. I will give you a couple to practice on. Let's just do one of these examples here real fast, and then we'll be done. So we have a right angle. So if we plug into this, we have 90 over 360 times pi r is 10 squared minus 1/2 10 squared times sine of m, which in this case was a right angle. Again, for these, I just recommend plugging the whole thing into the calculator. We're not going to do a lot with that one. I probably won't even test you on the segment, to be honest. But 90 divided by 360 times 3.14 times 10 squared. So that's that first part of it. The other part, 0.5 times 10 squared times sine of 90, that's 50. Subtract those two, 28.5. Again, not the easiest one, and didn't realize that it was off the screen. Guys, if I ever go off the screen during a live session, you're more than welcome to unmute yourself and say, hey, you're off the screen. It's hard for me to look at the chat constantly, but there it is. Again, just plugged it straight into the formula. All right. Again, this live session is pretty much just to go over new things. So I'm sorry it took 7 minutes. I had talked a little bit about other things at the very beginning. Any questions?
Hey, Mr. Spizak,
Yes.
can you show the sector of a circle?
The sector of a circle?
I missed
The
that
equation at the top?
part. Yes, sir.
That part?
No, slightly above it, the diagram.
Slightly above it.
Yeah.
Oh, this piece?
Yes, I missed it.
Okay, yeah, so again, the sector of a circle, it just looks like a slice of pizza, basically. I did see a couple
Thank you.
people add just recently. Again, if you're adding right now for my next class, I'll start that in a little while. I'm not starting that until 11:15.
So I just have to come out to one of these each week?
You only have to come to one. Again, I will always record and post these on Edsby, so you don't have to attend every single one of them. Again, that's optional. If you have questions and stuff, then you can ask me while I'm live. Again, I normally don't expect it to take as long as it did for this lesson. It took a little longer because we had a little extra stuff to go over at the beginning since this was our first one. But again, I'll try to keep the notes to less than 30 minutes on a normal basis. I think I took 35 minutes total for the notes. So again, I'll try to keep it a little bit shorter.
Thank you.
Yep.
I'll unmute myself now.
Anybody else move the paper up? You want which part of it? This piece?
Can you show please the last example?
The last example?
Yeah, that one.
This one?
Yes, thank you.
Okay. Anybody else have questions? All right. If there are no other questions, then that's it for today. You guys can go ahead and sign off. Again, I'm going to leave this. I'm going to actually close the session real fast and then reopen it for my next class. All right. So if you're already here for my next class, just give me a minute to stop it, save the recording, and then I'll be right back on.